Good day, everyone. My name is Thabo Ramano, and I will be taking you through computer networking in Java. And then I will hand over to Gavin, who will take you through some of the practical implementation of implementing a client-server model using Java. So the agenda is I'll be talking about what a computer network is. I'll be talking you through some of the components used in a computer network. I'll then take you through what a network topology is, and then I will talk about Java socket programming. So what is a computer network? So a computer network is a group of devices connected to each other by means of some form of a communication channel. So these devices have to be two or more. So as you can see from the diagram here, I have device A, B, C, D, and E, and I have a printer. And all these devices are connected by means of this communication channel here. So what exactly is a communication channel? It's a medium that is used by network devices to transmit information between the different network devices. So as you can see here, we have A, B, C, D, and E, and they're all connected to each other by means of this cable here. So an example that I gave you here is like a cable. So this cable here connects all these devices together. And we have different types of cables. We have a coaxial cable, a twisted pair cable, as well as a fiber optic cable. So all these network devices are connected to each other by means of a communication channel. So these devices that are connected in the same network can actually share or access a shared resource. They are able to communicate with each other as well as share data amongst each other. So as you can see here, so these devices here, so for example, A is able to communicate with B. It's also able to communicate with device C, E, and D as well, and as well as the printer. And they're also able to share data amongst each other. So you can have A sharing data with E, D sharing data with C, and all this is possible because of this communication channel that exists here. And another thing is, as I said, devices are able to share, or if in the same network, they're able to share a shared resource. So in this example, I use a printer. So all these network devices here, A, B, C, D, and E, are actually able to share this printer. But sometimes there are situations that occur where accessing shared resource can cause a lot of issues. And the issue that I'm talking about here is a race condition. So a race condition occurs when two or more processes try to access the same resource at the same time. So going back to this example, if we have device A wants to use a printer, so it's accessing this printer, and then we have device B as well accessing the printer at the same time as A, then we have the shared, the race condition. So there are ways to avoid a race condition, and that is by setting up something known as a critical section. And this critical section is executed as an atomic instruction, which means it's one thread at a time. So going back to this example again, so if A wants to use the printer, it then we then set up this critical section. So that means by setting up this critical section, that means if B wants to then access the printer, it will be denied access because of that critical section. So once A is finished using the printer, it goes away from this critical section, and then B then enters the critical section. And if B is entering the critical section, then C then it will not be able to use the printer as well. And that's basically how you actually avoid a race condition. But there are other ways you can use to avoid race conditions. So these are just some of the components used in computer networks. There are more. So we've got the router, the repeater, switch, server, the client, as well as the transmission mediums. So everything up to the transmission mediums are actually known as your hardware components. And then we also have our software components here, which are the operating systems and the protocols. And we do have more components used in computer networks. Just for interest sake, for those who want to know what a protocol is a set of rules that govern how network devices communicate with each other or share data amongst each other. So now let's look at some of the network topologies. So we'll begin by actually explaining what a network topology is. And it's just basically a way of representing the arrangement of network devices. So it's just a way we arrange or the way network devices are arranged in a specific network. So we've got different types of networks here. There are more. I just listed 3 here. So we've got a bus topology, which I think you've seen in the first slide. We've got a ring topology, which is arranged in this way, almost sort of like a ring. And we've got a star topology, which is this one here. So if I go back here, you'll see that this here is actually an example of a bus topology. And each of these topologies actually have their own advantages and disadvantages, which I'm not going to take you through now, just something to note. So now I'll be talking about Java socket programming. So we have a client and we have a server. So that's just basically just going to start you off there. So we have the client and we have a server. So the client will request a service from a server, and then the server will then respond to the client's request. So now the client isn't able to connect to the server if the server is not running. So we need to make sure that the server is actually running. So if the server is running, then the client is able to then connect to the server. So I'll just repeat, we have a client, we have a server. The server is only able to request a service from a server, or let me say connect to the server if the server is actually running. And then once the server is running, then the server is then able to respond to the client's request. So what is Java socket programming? It's basically having different applications communicate with one another, even though they are running on different runtime environments. So in Java, we actually call that a JRE, which is a Java runtime environment. So if we have a client running on a runtime environment, we have the server running on a different runtime environment. Through the use of this Java socket programming, they are actually still able to communicate with each other. So we can have, so for Java socket programming, we have connection-oriented as well as connectionless. So in connection-oriented socket programming, we use the socket as well as the server socket. And for connectionless socket programming, we use a datagram packet as well as the datagram socket. So for connectionless socket programming, it's basically where the packets are not guaranteed to arrive to their destination. So there's no guarantee that all the packets will arrive to the destination. For connection-oriented programming, it's different. It's the packets are guaranteed to actually arrive to their destination. So that's just the difference between using a connection-oriented socket programming as well as the connectionless socket programming. So this is the socket API. So we've got the client and we've got the server. So the server listens for requests from the client. So once the client connects and you request a connection from the server then accepts the request from the client. Then we basically say that the client has connected to the server. So once the server accepts the request for connection by the client, then we say that the client has connected to the server. And then here is just where the client's server session occurs, so we can read and write files. And then once the connection is done, we close the connections, and then the server will return back to this state where it is open to listen to more requests from different clients. So just to reiterate again, we have the client, we have the server. The server listens for requests from the client. Sorry, it listens for requests from the client. And then once the client requests a connection from the server, then the server then accepts the request from the client, and then we basically say that the client has connected to the server. And after all the session is done here, then the connection is closed, and once the connection is closed, the server will then return back to this state here where it is open to listen to requests from the client. So that is the socket API and just generally how it works. So what is a socket? A socket is basically used, so we use it basically when programming in the client side. So it's basically used for communication between the client and the server. And so this socket takes in 2 parameters. It takes in the IP address of the server it wants to connect to, as well as the port number. So you'll see that when we talk about server socket, you'll see that the port number is basically where the server actually listens on. So that's why the socket in the client side actually needs the port number, because the port number is where the server listens on, as well as the IP address of the server. So this is basically the syntax for the socket. So it's socket, then the client socket object is equals to new socket. And you'll see that it takes in the IP address, the server IP address, as well as the port number. So everything done here in the socket is basically done in the client side. And then we also have the server side. So the server side, we use server socket. And so this is used in the server to basically listen for requests from the client. And it only takes in one parameter. And that parameter, like I spoke of, is the port number. So the port number is basically the number it listens on to listen for requests from the actual client. So the syntax for the server socket is server socket. Then we have the server socket object is equals to new server socket, as well as the port number here. So when the server socket accepts the request for connection from the client, it uses an accept method. So this accept method basically is used to accept connections from the client. And once the client has successfully connected to the server, we say that the client is connected to the server. So just to reiterate, on the client side, we have the socket, and this socket basically is used to communicate between the client as well as the server. And it takes in the server IP address as well as the port number. And in the server side, the port number is the server socket basically takes in the port number in which it listens for requests from the client. And then it uses this accept method to accept connections from the client. So I'll now be handing over to Gavin, who will be taking you through the practical implementation of the client-server model using Java. Thanks.
Good afternoon, ladies and gentlemen. My name is Gavin, and I'm a grad at BBD. So today I'll be presenting how to create a web server in Java, and then I will be taking you through various topics such as the I'll be taking you through various topics such as the Java socket programming, design and UML, activity diagrams, and then I'll go on to demo the actual server. So nodes on the network, as Tabo has already shown you guys, you've seen computers connected to each other. So they could be connected using Wi-Fi, they could be connected using a LAN cable. So those are actually nodes on a network. So a node on a network is just any device that is actually on the network. So if my laptop is on the Wi-Fi and there's also another laptop on the same Wi-Fi, then I could say those two devices are nodes on the network. So it can be possible for one laptop to be a server if it runs the server program, and then the other laptop to be the client if it connects to that server. So for example, if my laptop has a web server running and that laptop opens up the browser and then reaches out to my IP address on the port number that the server is listening on, what will happen is that my server should respond to that client because they are connected and they're on the network, on the same network. So as the server usually listens for connections. Tabo might have mentioned that the server must always be running and up all the time. So the server runs and then the client connects, and it must always be up and running. So I have created an HTTP web server using the Java programming language, which has files on its file system. So the server has files on the system, and then the client could be another machine or also my machine. If I open Google Chrome, for example, and connect to my local server, the browser is also regarded as a client. So the browser usually it sends in the HTTP request to the server, and the server must respond with an HTTP response. So as Tabo also mentioned, there are protocols, which are a set of rules that govern how the server and the client communicate. So using HTTP, you will see that the server, the client sends in a request string that has some set of rules. For example, it should specify if it's a get, if it wants to get files, if it's a put, if it wants to update something on the server, and many more. So I will be moving on to show you guys how I've designed the program itself. And then by demonstrating to you guys how the UML diagrams and also how the objects are linked up together. So as you can see on the screen, we have the HTTP server object. Now this server object has two attributes, which is the server socket and the running attribute. The running attribute is just a Boolean which that states whether the server is running and then or not. And then I don't actually have a method to change this running variable because it should always be true, as the server must always be running. So what happens is that the HTTP server has this handler object. The handler object, what it do basically is that it runs on a thread. So when a client, for example, when a web server requests a resource from my web server, this handler object is instantiated and then it is put on a thread. That's why it implements the runnable interface. So it will the handler object will be created and then it will be put on a thread, and then that thread will start so that the HTTP server can continue to listen for other client connections. I will demonstrate that further on my next slide, which is the activity diagrams. So as the handler is instantiated for each client, what will happen is that the handler will execute this run method in a loop, meaning that it will continue running as long as that client is connected to the server and it's on a thread. So what will happen is that the web browser will send in a request to the server. The browser will contain the method, path, version. I'll be focusing more on the method and the path because I'm not going to be using the HTTP version much. So what will happen is that we'll receive a response, for example, get / and then the HTTP version number. So what will happen is that the server will interpret that response and create a response, and create a request object if that request is valid. So for example, if the client is looking for an index.html page, that path will be / index.html. If the server sees that, okay, the file is available and it's actually a get method, because for our server, we're just handling the get method because it's a small server. If it's a get method and the resource is available, meaning that the index.html file is on the server, it will create a response object. The response object will contain the code, status, content type, content length, connection, and also the interesting part here, the data output stream. The data output stream is just to send the file back to the client, so if it's available. But in cases where the file is not available, we'll send the response code 404, and then we'll send the 404 file, HTML file, so that the browser can interpret and know that the file that I was looking for is not available in the server. So I'll move on to explain further the activity diagrams of our system. As we can see, we'll start on my right. We have the HTTP server. The HTTP server, once it starts, it waits for client connections, meaning that the server will run and listen for any client who wants to connect to it. And then if there's no connection, it will just keep staying on that loop of listening for connections. And then if the connection is established, for example, we'll create the client handler object. The handler object is just that object that will run on a thread as long once the connection is established. Once the thread has started, what will happen is that the server will continue listening for other connections in case where another person on a different machine tries to connect to the same web server. And then for that client that is connected and the thread that is started, will move to this handler and actually read the request string. The request string can be something like get / and then also the HTTP version number, which is just the protocol for communicating with the HTTP server. And actually the HTTP server communicating with the browser. So we will read this request string. If the request string is empty, we'll just look for for another request string, because there are cases where the browser sends in an empty string to the server. And if the request string is valid, for example, we do know that the request that the browser is looking for is actually a valid request string. We will create the request object. And then, and since, like I've said, my server only handles the get for now, we will check if the request method is not get, we'll continue listening for other request strings. So if the request method was valid, so we'll take this path and then check to see what resource actually are we looking for. If we're looking for the default resource, which is just the index.html, we'll send the default file. We'll just go through this route and create the response object, send the headers, and then send the default file. Else, we will create a response object, send headers, and then we send the requested file because it will not be the default index.html file. So let me take you guys through my through our demo to show you guys how the server actually works and how it's implemented. So here is my server. I'll just quickly destroy everything and then I will restart the server. So we can see down here on the console that there's starting up the server. Server has started and then it's waiting for client connections. So meaning that we can just go ahead and open a browser and then connect to that server. So let me just open this side by side so that you can see exactly what is happening. Localhost. So here's our website. We can see on the console that this is the request I was telling you guys about, the get/http version 1. So this is just the method and this is just the path. So as I've explained, if the path is just a /, then we know that we're looking for index.html, and then here we have method, path, and version. So there are also some stuff that the web browser has requested. As you can see, it's not just the index.html file. If I refresh this, you will see that it requested also the styles.css, the video as well, the video that you're seeing on the screen, and also the icon, which is actually the icon right there at the top. So my server actually, it does handle HTML, CSS, JavaScript, MP4, and also the images. So I'll just browse through the images. Oh, actually, let me just play the video to show you guys that it actually fetched the video from the web server, and it's actually going to play the video. And then images, there it also did fetch the image from the web server. And then if maybe someone requests something that is not on the server, it will just give us this page that nothing was found. And you can see over there the status code is 404, and then it says not found, and that's actually the response from the server itself. So to also demonstrate threads, I'll open two browsers and actually access localhost on the other browser as well. Just to show you, just to demonstrate that actually each and every browser's request to connect to the server is actually handled on a thread, meaning that we can connect as many clients as we want, and we can fetch as many resources as we may want to request from the server. So actually, that's actually it from the server itself and the resources that are fetched from the server. And we will see that it's still up, and the server is always still up and running. Just getting this error message because of the connection, my internet VPN and connections.